So if we look at the sixth chemical reaction, that is what the formation of acid chloride. Well, how the acid chloride is obtained from acid? I have the acid RCOOH. If I react the acid with phosphorus pentachloride PCl5, then it gives RCOCl plus HCl plus phosphorus oxychloride. So this is acid chloride is obtained. This is acid. That means from acid, the acid chloride can be easily obtained. That is, if acid reacts with phosphorus pentachloride, then it gives the acid chloride along with the hydrogen chloride, and the phosphorus oxychloride is produced. Phosphorus oxychloride. If I will give you the specific example, CH3COOH. What's the name of this compound? CH3COOH means acetic acid. When this acetic acid reacts with phosphorus pentachloride, then CH3COCl, acetyl chloride. Acetyl chloride with hydrochloric acid along with POCl3, that is phosphorus oxychloride. Phosphorus oxychloride is obtained here. So acetyl chloride, that means how the acid chloride is obtained? The formation of acid chloride can be taken place when the acid reacts with PCl5. So the acid chloride can also be obtained if the acid reacts with SOCl2, that is thionyl chloride. When the acid reacts with thionyl chloride, then RCOCl, sulfur dioxide plus HCl. Yeah. So if the acid reacts with thionyl chloride, then acid chloride is obtained, no doubt. But one more product that is obtained here, that is sulfur dioxide. Since it reacted with thionyl chloride, that is SOCl2, that's why the sulfur dioxide is obtained and hydrochloric acid is removed from here. So here we have discussed the two things. One, the formation of acid chloride. When the acid reacts with phosphorus pentachloride, it gives acid chloride. But other two byproducts are HCl and POCl3. But if the acid reacts with SOCl2, the thionyl chloride, it gives the acid chloride, but sulfur dioxide is removed here. So the byproducts are sulfur dioxide and HCl. So let me give you the specific example so that you can understand clearly. I have CH3COOH. So what is the name of this compound? Estric acid. When this acetic acid reacts with thionyl chloride, it gives CH3COCl, acetyl chloride. Acetyl chloride, then sulfur dioxide, then HCl is removed here. So in this way, this is the specific example wherein the acid chloride is formed by the reaction of acid with thionyl chloride. So the formation of acid chloride can be done in the different ways like this. Well, if we will take, suppose if you will take, you see, here the space is not eligible, space is not required. That's why we will discuss how, the acetic anhydride, how the acetic anhydride is prepared from acetic acid. Now let us try to understand that how the acid anhydride is obtained from acid. Suppose I have acid RCOOH. When it reacts with phosphorus pentoxide P2O5, then it gives RCO water. This is acid anhydride. So I have taken a mixture of acid, and if that mixture of acid reacts with phosphorus pentoxide P2O5, it gives, you know, RCOO, RCO, RCO, and here it is O. Yeah. So acid anhydride is obtained with the water molecule. Let me give you the specific example. Suppose I have CH3 COOH. CH3 COOH. If the acetic acid reacts with P2O5, or when it is heated with phosphorus pentoxide, then CH3CO, CH3CO, this is O, and water. Acetic anhydride. Acetic acid. Yeah. So when acetic acid reacts with phosphorus pentoxide, then it gives the acetic anhydride, that is CH3CO and O. A mixture of acid reacts with this one to give the acetic anhydride. In this way, the acid anhydride is obtained by the reaction of the acid with the phosphorus pentoxide. So the question comes in the examination that how the acid anhydride is obtained from acid. That means you need to say that when acid reacts with phosphorus pentoxide, then acid anhydride results with the liberation of the water molecule. And putting CH3 in the place of R, I have given you the example. Well, this is about the formation of acid anhydride. Now we will discuss some of the reduction. That means if the acids are reduced, then what happens? Now we'll discuss. So if the acid, so I have acid. If that acid gets reduced, reduction means addition of hydrogen. So the reducing agents like lithium aluminum hydride, if I have taken RCH2OH, the primary alcohol is obtained. This is acid. So the simple thing that you need to remember, when acid gets reduced, what happens? Alcohol is obtained. That means acid reduces to form alcohols. So let me give you the specific example. I have CH3COOH. This is acetic acid. When the acetic acid reacts with hydrogen, or when it reduced in the presence of lithium aluminum hydride, then CH3 CH2OH. So what is the name of this compound? Ethyl alcohol. So ethyl alcohol is obtained if the acetic acid gets reduced. At the same way, if the acetic acid gets reduced in the presence of copper chromite, then it gives CH3 CH2OH. The same ethyl alcohol is obtained. Yeah. So when acetic acid, so CH3COOH means acetic acid. If that CH3COOH gets reduced in the presence of the reducing agents like lithium aluminum hydride, then ethyl alcohol is obtained. If that same acid reduced with copper chromite, then also ethyl alcohol is obtained. That means when acid gets reduced, no doubt the alcohol is obtained. So this is the reduction. Now we will discuss how the aldehydes and ketones are formed from this acid. So now the question is how aldehydes and ketones are prepared from acid. Suppose you see I have RCOO, Ca. This is calcium salt of acid. When this calcium salt of acid reacts with calcium formate, calcium salt of acid. When this calcium salt of acid reacts with calcium formate, then what happens? The CaCO3, the CaCO3 is removed from here. That is 2 CaCO3 is removed from here, and finally it gives 2RCHO. 2R and C, 2H, 2C and HO. So 2CHO, that means aldehyde results. Let me give you the specific example. Suppose if I will place here CH3COO, CH3COO. This is calcium acetate. When this calcium acetate reacts with HCOO, this is calcium formate, then the calcium carbonate is removed from here, and it gives the 2 molecules of acetaldehyde along with 2 molecules of calcium carbonate. So acetaldehyde is obtained. So remaining 2 CH3CHO is there. If you will eliminate this calcium carbonate from both the compounds, then you will get CH3CHO, acetaldehyde. Now the point is, if the calcium acetate is alone heated, then what happens? I have CH3COO, CH3COO. When this calcium acetate is alone heated, then calcium carbonate is removed, and finally it gives this is acetone, and acetone is obtained. Similarly, if you will take HCOO, this is calcium. If you heat this one, then calcium carbonate is obtained, calcium carbonate is removed, and finally I have HCHO plus calcium carbonate. This is formaldehyde. So this reaction is also one of the most important reaction to remember, that how the aldehydes and ketones are formed from the acid. When calcium salt of acid, that is RCOCA, reacts with calcium formate, then from both the compounds calcium carbonates are eliminated. First of all, the first step that you need to do is that you need to eliminate the calcium carbonate CaCO3 from both the compounds. Then what is remain? That is 2RCHO, that is aldehyde is obtained. But if you will take the specific example, that if a mixture of calcium acetate and the calcium formate are heated, then acetaldehyde results. Of course, no doubt the calcium carbonate is removed, but what is product here? Acetaldehyde is obtained if you will react with this two. But if you will heat only this calcium acetate, then the calcium carbonate is removed, and finally what we have? CH3CO. This is acetone is obtained. If this only, that means if only calcium acetate is alone heated, then acetone is obtained, which is a member of the ketone. If calcium formate is only heated, then the calcium carbonate is removed from here, and finally we have HCHO, that is formaldehyde. That means the formaldehyde can be prepared when calcium formate is only heated. The acetone, that is the member of ketone, can be prepared when the calcium acetate is only heated. So if calcium formate and calcium acetate both are heated in the mixture, then you get the acetaldehyde. So this reaction is very, very relevant because it often comes in the examination, that how the aldehydes and ketones are prepared from the acid. Or sometimes the question is it's being asked that how the acetone is prepared from the acid, or how the formaldehyde is prepared from the calcium formate. So this is what we have to remember from here, that is the formation of aldehydes and ketones. Now we will discuss that how the alkanes are formed from acid. So here we will try to understand that how the alkane is obtained from here. Suppose I have sodium salt of acid, that is RCOONa. When this RCOONa reacts with NaOH, in the presence of CaO, calcium oxide. So the NaOH and the CaO, this is caustic soda and this is quicklime. So this caustic soda and the quicklime together we call the soda lime. So what do you mean by soda lime? Soda lime means nothing but NaOH plus CaO. Because this is caustic soda, which we remember it as soda, and here it is calcium oxide, which is a quicklime. So this is soda lime. So when the sodium salt of acid reacts with the soda lime, it gives alkane along with Na2CO3. That is, sodium carbonate is obtained. This is sodium salt of acid. If I will take the specific example, I have CH3COONA plus NaOH, CaO, calcium oxide, it reacts with NaOH, CH3CO, sodium acetate, and it gives CH3H, that is methane, plus Na2CO3, sodium carbonate is obtained. But anyhow, the methane is obtained. That means in this way the alkane can be easily obtained by the reaction of soda lime with sodium salt of acetate. That is, CH3COONA reacts with soda lime to give the methane along with the sodium carbonate. So this reaction is very simple to understand, I think, for you. Alkane can be easily prepared when the sodium salt of acid reacts with soda lime, and the specific example was also given. Now we'll look at the last one. If the acid reacts with, suppose I have acid, if the acid reacts with chlorine, that means reaction with chlorine, if the acid reacts with chlorine, what happens we'll see. Suppose I have acetic acid, CH3COOH. If the acetic acid reacts with chlorine in the presence of the phosphorus, then HCl is removed. This HCl is removed, and here it gives one hydrogen is removed, and in the place of that hydrogen, the Cl, the chlorine is the chlorine is actually attached to ClCH2COOH. So this is monochloroacetic acid. Monochloroacetic acid. If it is again treated with chlorine in the presence of phosphorus, then again HCl is removed, and it gives now it becomes dichloro. One more hydrogen is removed, ClCOOH. So what is the name of this compound? Dichloroacetic acid. Dichloroacetic acid. If that dichloro again reacts with chlorine in the presence of phosphorus, then one more hydrogen is removed, and it gives COOH. This is trichloroacetic acid. So look at here. This is, first of all, I have taken acetic acid. When this acetic acid reacts with chlorine molecule, then one Cl, the Cl is there and this hydrogen. So the hydrogen and one Cl will be removed. That means HCl is removed and one more Cl is there. That Cl will be attached to, substituting the hydrogen atom of the methyl group, it will be attached here, and finally it gives Cl. The Cl, and here CH2 is there. So Cl, CH2, COOH. So hydrogen chloride, anyhow here it is obtained. So monochloroacetic acid. And if that monochloroacetic acid on further reaction with chlorine molecule, HCl is again removed in the presence of the phosphorus, and it gives the dichloro. That means one more chlorine will be attached and this hydrogen is removed. Yeah. So the removal of this hydrogen is removed. This hydrogen, it's not about this hydrogen. And dichloroacetic acid is obtained. And if that dichloro again treats with chlorine molecule, then the chlorine will be attached again and one more hydrogen will be substituted, and finally it gives CH3CCOOH, that is trichloroacetic acid. And you should remember this reaction is called Hell-Vollard-Jelinski reaction. This is the naming reaction, which is very much important to remember. You can shortly remember it as Jelinski reaction. Well, this is all about the reaction with chlorine. That means when the acid reacts with chlorine, then what happens? Then monochloro, then dichloro, then trichloroacetic acids are obtained. And now we will discuss the last one of this carboxylic acid. That is, what is the difference between the formic acid as well as the acetic acid. So here we will look at some of the special reactions of the formic acid. That means the formic acid has the ability to reduce the Tollens reagent. On the other hand, the acetic acid cannot. Well, the formic acid reduces with Tollens reagent. So Tollens reagent, ammonical solution of silver nitrate is known as Tollens reagent. When that formic acid reacts with ammonical solution of silver nitrate, then it gives, first of all, ammonium formate. Ammonium formate, then ammonia, water, and most importantly the silver mirror is obtained. So what we need to understand here, the formic acid can reduce the Tollens reagent to form the silver mirror. Yes, and other such special reaction of formic acid is that the formic acid, it can be oxidized in the presence of this potassium permanganate or the sulfuric acid to form the carbon dioxide and the water molecule. So this is also one of the special reaction of the formic acid. It can react with the potassium permanganate or sulfuric acid. Similarly, it can also reduce the Fehling solution. So when the formic acid reduces the Fehling solution to give the water, carbon dioxide and cuprous oxide. This is also one of the most important thing that we need to remember. That means the formic acid not only reduces the Tollens reagent, but also it reduces the Fehling solution. And what is Fehling solution? That I had already explained you in the previous lecture. And the next one, when formic acid gets heated, then we get the carbon dioxide and the water molecule. Sometimes there may be a question in the examination, what happens when formic acid gets heated? Formic acid gets heated at 433 Kelvin to give the carbon dioxide and what? H2, hydrogen. Similarly, when the formic acid reacts with concentrated sulfuric acid, then water and carbon monoxide is obtained. This question also may be there in the examination point, what happens when formic acid reacts with concentrated sulfuric acid? It gives water as well as carbon monoxide. Similarly, if formic acid reacts with phosphorus pentachloride, PCl5, then it gives HCOCl, 1Cl, that HCOCl, formyl chloride is obtained along with hydrogen chloride, and that formyl chloride on further heating, it gives the carbon monoxide along with the hydrogen chloride. And I wish you understood the special reactions of the formic acids. So why we need to so much emphasize about the formic acid? Because the formic acids have some special characters where it can react with many more things. It reduces the Tollens reagent, it reduces the Fehling solution, it reacts with concentrated sulfuric acid and much more. That's why here I have written the special reactions of the formic acid. Now we will look at some of the uses of the acids along with the differences. Well, if you look at the uses of the formic acid and acetic acid, look at here. Formic acid is used for removing the limes which is in the textile industry. So the first use the formic acid that we require is it is used to remove any of the limes in the textile industry. And the formic acid is also used in the dyeing textiles, because you see there are many more textile products, and in order to color the textile products, to dyeing that means in dyeing textiles, the formic acid is used as a very important substance. And the formic acid is also used as a coagulating agent for rubber latex. This is also the use that you need to remember. For a rubber latex, it is used as a coagulating agent. And for storing and generating, the carbon dioxide gas, the formic acid also plays a very important as well as the significant role. I hope that you mention or you take a screenshot of the uses of the formic acid as well the acetic acid. So what are the uses of acetic acid? The acetic acid is used as a very good solvent for many of the chemical reactions. And the acetic acid is also used for curing the meat as well as the fish items, because if you see there are meat and fish items, in order to get away from the bacteria, or in order to be safe from the bacteria, acetic acid, which is called the vinegar, a vinegar is slightly poured on the meat and as well as the fish, so that no bacteria can attack on that, and in this way the acetic acid can cure the meat and fish. It is also used for coagulating the rubber latex, which is having the characteristics with formic acid as well. And the acetic acid is also used for the manufacture of the acetates, esters, and the various products, etc. But now the question is, can you explain distinguish the different tests of the formic acid and acetic acids? Yes, the formic acids can be identified by the different tests, along with the acetic acids can also be identified the different tests. Well, formic acid, when it reacts with concentrated sulfuric acid, it results the carbon monoxide. That is the first test where to distinguish a formic acid. And it reduces the Fehling solution. It reduces the Fehling solution to give a red-brown precipitate of the CO2 or cuprous oxide. That is also one of the tests that wherein we need to identify, wherein we need to recognize. It decolorizes the acidified potassium permanganate, and it forms a white precipitate of the Hg2Cl2. That means this is also one of the tests. So here I have written the 3 tests for you. One, the formic acid reacts with concentrated sulfuric acid to form the carbon monoxide. And second, it reduces the Fehling solution to give a red-brown precipitate of the Cu2O. And third, it decolorizes the KMnO4, acidified KMnO4, and it gives a white PPT of Hg2Cl2. So what is the test of acetic acid? The test of acetic acid, I have written here the 2. One is the acetic acid. The acid reacts with the alcohol to form the ester. That is the first test. That means the esterification is also one of the tests. And next one, the vinegar-like smell. The acetic acid having the characteristics of the vinegar-like smell. So I think that these 2 are the most relevant for the testing of the acetic acid, as well as these 3 are very important for the testing of the formic acid. So this is all about, we have here we have discussed the uses along with the tests of the formic acid as well as the acetic acid. And at last we will discuss here the uses or the differences between formic acid and acetic acid. So if we look at the difference between formic acid and the acetic acid, the first difference that we can say, the formic acid is a strong acid and acetic acid is a weak acid as comparing to the formic acid. So why the formic acid is stronger than that of the acetic acid, I have explained you in the previous part of the video lecture. I hope you see that one. And another difference is that when the formic acid is heated at 433 Kelvin, it gives the carbon dioxide, or carbon monoxide and hydrogen gas. And further on, if it reacts with concentrated sulfuric acid, it gives the carbon monoxide and water. But here, it is stable to heat the concentrated sulfuric acid. It reacts with concentrated sulfuric acid to give the carbon monoxide and water, but here it is stable. The third difference is that the formic acid does not undergo the substitution reaction with chlorine. On the other hand, the acetic acid undergoes the substitution reaction with the chlorine, and it gives the mono, di, trichloroacetic acids, which we had already discussed previously. The fourth difference is that the formic acid, on fused with soda lime, that is NaOH plus CaO, on fused with the soda lime, it gives the hydrogen is obtained. That means hydrogen is formed. So when formic acid is fused with soda lime, hydrogen is obtained. But when acetic acid is fused with soda lime, then alkane, that is a methane, is obtained. And that's the difference that we need to remember. And at last, the difference I would like to say is that the formic acid is having the tendency to reduce the Tollens reagent as well as the Fehling solution. It can reduce the Tollens reagent to form the silver mirror, and the formic acid can also reduce the Fehling solution to form the red-brown precipitate of the Cu2O. but here the acetic acids do not reduce the Tollens reagent as well as the Fehling solution. So that is the difference between the formic acid as well as the acetic acid. And here we have completed the entire things, starting from the methods as nomenclature of carboxylic acids with examples and methods of preparation, chemical properties, everything of carboxylic acids. And I hope you understood. And if you are having any query regarding to this, you can put it in the comment section. And if you would like to watch the next chapter of the video lectures, then I would request you to press the bell icon over here to get the latest notification. Thank you very much for watching.